Resultant moments. A uniform beam of mass 10 kilograms will have a weight of 98 newtons, which acts right at the center. The beam is placed on this object, and this point, the pivot point, is right at the center of the beam, creating a seesaw. And there is the weight force acting at the pivot point here at the center, and a normal reaction. If we were to take moments at this point, then both of these will produce 0 moments, because the perpendicular distance from the force to the pivot point is 0, so we can safely ignore these. Example 1. So we have a seesaw that's currently being held by this person, so it stays in a horizontal position. We have a pivot point here at the center. At the center we also have the weight of the beam, and we have the normal reaction between this pivot point and the beam. Now, because both of these two forces will be where we take our moments at the pivot point, they can be ignored. They will both produce 0 moments. So when the person lets go, one of 3 things can happen. Either the seesaw remains balanced because the clockwise and anti-clockwise moments were equal to each other, or one side can go down, or the other side can go down. So we will calculate moments to determine what happens. So I'm going to take the clockwise direction as positive for my moments, which means the anti-clockwise direction will be negative. You don't have to state both of these, it's usually the positive one you write down, the other one's obvious. And then using the formula, we're going to calculate moments. So we have 117.6 newtons force times perpendicular distance from there to there, 2.2 meters. And this is a force that would push the seesaw down in this direction, producing a clockwise moment, so it's positive. And now for the next force here, 88.2 newtons times its perpendicular distance. Again, it will produce a moment in this direction because it wants to push the seesaw down on this side. That's going to be clockwise, so it's positive. And then we have the 294 newton force times the perpendicular distance here, and this time be on the other side of the pivot. So if this side was to go down, because the force is trying to push down on this side, producing an anti-clockwise moment, so it will be negative. So we simplify. Our final answer is a positive value, 11.76 newton meters. If it's positive, then we have a clockwise moment. The resultant moment is clockwise, so clockwise, clockwise. So this side of the seesaw goes up, this side will come down.